Okay, everyone, here is a quick tutorial video for all of the RM targets, and there's 4 of them. They don't really go in order. This first one is about the conservation of mass. And you've probably heard this before, but that just means that mass can't be created or destroyed. That whatever atoms you start a reaction with, you end the reaction with those same atoms, just in like a rearranged version. So before we got quarantined, we did a demonstration in class where I took some magnesium metal, which is like a strip of metal, and oxygen gas, which was in the air, and I lit it on fire with a Bunsen burner, and it made a white powder at the end of that reaction. And that white powder had totally different properties than the magnesium metal and the oxygen gas because these two atoms combine to make a whole new chemical. But they didn't change what atoms were there. They're still magnesium atoms. They just now combine with oxygen atoms. So we didn't lose or gain any atoms. We didn't make or destroy atoms. We just rearranged the atoms. So if we were to put them on a scale, these two things put together would weigh exactly the same as this. So no matter what, absolutely no matter what, whatever atoms we start with have to weigh the same as whatever atoms we end up with. Even if they look different, the same atoms are still there. Now, sometimes you might see a change in the scale since we added oxygen atoms from the air, that if we were to weigh the magnesium metal, it would weigh more at the end. But that's not because we've made atoms. That's because we added oxygen atoms that were in the air at the beginning to the magnesium that we had to make a new substance. So if you were to put that on a scale, that we would see the mass go up. Same thing happens if you were to like burn a stick. The stick would weigh less after you've burned it because you saw a bunch of smoke go up, and those are atoms leaving. So unless you see atoms going in or atoms going out of a reaction, you should have the same mass. That's what it means. Mass can't be created or destroyed. That's RM1. RM2 is probably the hardest one. This is balancing. And we'll get to that in a minute. That's what this tutorial video is going to be for. RM3 is pretty easy. That is products and reactants. And that just says that in every chemical formula or any chemical equation, there are things that you start with. Those are called reactants that go into a reaction. And there are things that come out that are called products. So again, to go back to that example that we saw in class, the reactants, the things that were going into that reaction, were magnesium and oxygen. And the products were that one powder, magnesium oxide. So another example here, these right here would be the reactants, aluminum nitride and chlorine gas. And they would make aluminum chloride and nitrogen gas. And then another example, this is the one that I told you I almost got fired for earlier in my career. I took methane gas, which is what comes out of the hoses in the class, the gas pipes, and I burned it with oxygen, and it made a fireball, but the released water and carbon dioxide. And the problem was I made soapy water bubbles that were flammable, and I put them on the principal son's hands, and then I lit them, and I burned the principal son's beard off. So I'll tell you that story a different day. Maybe I'll put that on my YouTube channel or my Instagram. But this is the demonstration that almost got me fired earlier in my career. So in that case, the methane gas, CH4, and the oxygen are the reactants, and then the water and the carbon dioxide are the products. And the last one, this is endo exothermic, which we've talked about that before with melting and boiling. This is energy in, this is energy out. Usually this means temp down because it's taking energy to do it, and this usually means temp up because it's releasing energy, which means that energy is coming out, and usually that energy comes out as heat. So let's talk about RM2. This is the one that is really a kind of tough skill. These two and that one are pretty easy, but this is the one that's going to really pay out for you. This is going to be really important in chemistry. So here's an example. Let me erase my little doodles. Here's an example that we did in class. Took magnesium and oxygen. We said we have the same atoms at the beginning that you have at the end. Now, it doesn't take a genius to notice here we've got Mg and here we've got OO. But on this side, after, we have Mg and O. So the question is, where'd the other go? Where'd the other oxygen atom go? And here's how we fix that. So first thing, this is extremely, extremely important. You cannot mess with the subscripts. You cannot change these things. This is a a 1 here and a 1 here and a 1 here. You cannot mess with that. Do not do that. Bad. The only thing that you can mess with are the coefficients, which would be right here. And so what you'll notice is that we need another oxygen atom over here. Now we can't just take only the part of that substance that we want. The chemical formula is fixed. So we are stuck. Even though this is the only part that we really want, we have to add both pieces together. So we change this coefficient to a 2. Now I've got 2 MgOs. 2 is our coefficient. Magnesium oxide, that's our chemical formula. And so that means we have MgO, NgO. This goes back to BC5 from last unit. Now, if you'll notice, we have a new problem because now we have 2 magnesiums on this side and only 1 on this side. That's a really easy fix. Change that to a 2, which means we have Mg. So our final answer here is 2 magnesiums, 1 oxygen 2 molecule produces 2 magnesium oxide molecules. So again, the whole thing that we're trying to work with here, you can only change the coefficients. That part, that part, that part. You cannot change the formula. So here's a slightly more complicated example. Again, these things are fixed by nature. ALN, that's a +3, that's a -3. This is the chemical formula for aluminum and nitrogen. You can't change that. Chlorine gas, Cl, comes with 2 together. Those are our reactants. And then on the other side, out of the reaction, we have aluminum chloride, AlCl3. This is a -1, this is a +3, so we need 3 -1s to balance that off. And nitrogen 2. That's how it comes in nature. So we can't mess with these formulas. All we can do is mess with the coefficients, the ratios they get combined in. So start off every time you do a problem like this, start off by drawing what 1, 1, 1, 1 would look like, because a lot of times that's all you have to do. So that would be, for this case, ALN, CL, CL, AL, CL, 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 and N, N. If we just had 1, 1, 1, 1, this is what we would have. Now the issue is that we have 1 Al here, we have 1 Al on that side. That's good. 1 aluminum, 1 aluminum. No problem there. 1 nitrogen, oh no. We have 2 on this side now. So what we need to do, we can't just, change that to a 1 because we don't like it. Not how things work. That's fixed by nature. Got to keep it. the only thing we can do is add another N to this side to balance it off. Now I got 2 and 2. But the issue, you can't just take the N. It's like a prepackaged thing. It comes with another Al, whether you like it or not. This is fixed by nature. So even though we don't need it, we have to take the whole thing. You can't just cherry pick the part you want. ALN, ALN. So now this would be, at this point right now, that's a 2. But we might have to change it later, so don't write it in yet. Okay, now, Al, Al. 2 on this side, 1 on this side. So we need to add another one, Al. But again, can't just cherry pick the part we want. Got to take the rest of it too, which means Cl, Cl, Cl. Try that again. All right, so let's double check again. Als were good. Ns were good. 2 to 2. Our problem now is we have 6 chlorines over here. 1, 2, 3, 4, 5, 6. On this side, we only have 2. So we need to add 2. Now we're set. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So looking back, 2 aluminum on the other side. We're okay there. 2 nitrogen, we're okay there. 6 chlorine, we're okay there. So the last thing we get to do is to fill in our our coefficients, which in this case would be a 2, a 3, a 2, and a 1. And then we're good. That one checks out. We're all balanced. I'll give you one more example. Again, these are our reactants, methane, CH4, and oxygen gas in the air. And these are our products, water and carbon dioxide, H2O and CO2. So start off, like I said the last time, draw out what 1, 1, 1, 1, 1 would look like. C, H, 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 O, O, H, H, O, and C, O, O. Now, if we just look at one element at a time, we got 1 carbon, 1 carbon. So far, those are okay. 4 hydrogens to 2 hydrogens. Okay, those are not okay. So, again, I can't just cross off the ones we don't like here. Doesn't work that way. We have to add more to this side. So if we had an extra H, H, and again, we can't just cherry pick the parts we want because this comes packaged with an O whether we like it or not. That's what our formula tells us up here. So now we've got, this would be 1, 1, 2, 1. Let's see if that works. 1 carbon, we're okay there. 4 hydrogens, we're okay there. 2 oxygens, 4 on this side. So we need more oxygens. Lucky for us, they come in packs of 2 because we need exactly 2. So now, I'm taking stock, I have 1, 2, 2, 1. Let's see if it works. 1 carbon to 1 carbon. Same atoms on both sides. Good. 4 hydrogens, We're good on that one. 4 oxygens, 2, 4 oxygens. So we are okay. This checks out. We have 1 of these, 2 of these, 2 of these, and 1 of those. This is a super, super duper common skill. There's probably going to be a lot of YouTube videos on this. So I tried to give you some simple resources and give you some simple examples here. I won't give you anything crazy. I don't think I have any examples that are over 7 for these coefficients. So if you find yourself writing 7 of these, you might still be on the right track. But if you go over that, I'd say you probably passed something a while back. One more important skill. If you're drawing this out and you look up here at your final coefficients and you find out that they can all be divided by 2 or sometimes even divided by 3, go ahead and reduce that fraction. That means that you kind of missed your point of balancing at some point in the past, and you've basically done the reaction 2 times, or sometimes you can even go around 3 whole times before you realize, oh wow, all of these numbers are divisible by 3. So these should be the least common multiple of all of the coefficients that you came up with. But again, the point is you have to have the same atoms that you go into the reaction with that you come out. You can't have a different number of any atom on either side, because that would break the main rule in chemistry, which is that mass can't be created or destroyed. So this is BC2. Draw out what 1, 1, 1, 1 would look like, and then just keep adding whole coefficients as needed until you get to a point where you have the same atoms on the left side as you do on the right side of the arrow. The very last learning target, BC4, is endothermic or exothermic. If you see the word energy on this side, that means that energy is going in to the reaction. So that would make it endothermic. If you see energy, the word energy on this side here, the product, that means that energy comes out of the reaction, and that makes it exothermic. So if energy is over here, it's exo. If energy is over here, that's endo. Hopefully that's helpful to you. Email me if you have any other questions. If you would like another few examples of these, I can make a YouTube video or another EduCreations video just like this one with more examples like this. So I'll probably post that up later this week. Hope you guys are staying safe. I really do miss you guys a lot, which is really strange for me to think that I really miss seeing my freshmen every day. But I do. I miss you guys a lot. But have a good one.